All right, so with the last class before the fall break here, today I was going to devote the entire time to a review. We probably won't take us the entire time to do the sample midterm that I've got here, so I'll open it up to questions or more exercises at the end if we really want to. Just a reminder that the midterm is the day that you come back from break. It's on Wednesday, October 17th, 1 week from today, during our normal time in the normal place. It looks like almost every row has plugins, but I would come with a fully charged battery in your laptop. Remember, it is required laptop. It's open book, open note, and required computer because you'll be doing live coding exercises and handing them in electronically. The web grader will be, the web hand-in will only be open for that hour and 15 minutes that you have for class. It won't be open before that. It won't be. It'll be closed within a few minutes after that. The web grader will be set up so you can run it as many times as you want. I will be up here monitoring it and killing anything that has infinite loops or anything like that so that it doesn't affect other people. There's no communication with anybody electronically or orally or otherwise in semaphore, whatever. No communication with anybody inside of class or outside of class. There's also no paper. I will not be handing out sheets of paper for you to do. Instead, I'll put a URL up on the screen or up on the blackboard. You go to that URL, so you do need internet access on your computer. You'll go to that URL and there'll be a PDF, and that will be the description of what you need to do. You will not hand anything. You won't hand anything in hard copy. It's all electronic. You hand it in through web hand-in. Right? There is some starter code may be provided. I'll show you an example here in a second of last semesters. The URL will be provided and embedded inside that PDF. The topics will include most everything that we've done up to this point, including basics, input-output, conditionals, loops, functions including pointers, pass by value, pass by reference, error handling, and arrays, both static and dynamic arrays. It will not include what we've most recently done, strings. Okay? Any questions on the format of the exam? Yeah, back there. Well, not during the exam, no. No communication at all. High-level questions on hacks and very high-level questions on assignments, sure. But an exam is, it's an exam. It's all on your own. Yep. Yeah.
Will we be able to ask you anything or other people?
Oh, you can, but I'm not going to guarantee that I'll answer it. Right. Okay. Yeah, way back there. Depending on the exercise, I might give you some starter code. I'll show you what I gave last year or last semester. It'll of course be different starter code, but it'll be relevant to whatever you're working on. Yeah, yeah, way back there. Yeah, you can bring. In fact, I would highly recommend that you bring your old code, understand your old code that you've written with other people in hacks, labs, or your own code from assignments. And now that the assignments are closed, assignment 1 and 2, you can feel free to share your code from those if you really want to. Now there's no risk of copying it because those are done. Now don't share any code from homework 3 yet until after the due date. But you can bring that code. In fact, I would suggest that you come prepared with some basic boilerplate code, a hello world program that you can just get started with so you don't have to type all of the basics like the includes and the main and whatever. Have your code from whatever you want, right? Yeah?
So if you provide starter code, will this file be graded?
Yes, it will be graded like normal stuff. So, style, documentation, design, and correctness. Those will all be categories that will be in the rubric. The way that we're going to grade it is just like we've been grading your stuff up to this point. You hand it in, the graders take a look at it, and they enter their scores into canvas. So we will be grading on style. Of course, if we provide the style, then why change it? You should put your name on it, of course. But if we give you a file and then a function and it has no documentation, put that documentation in there. Right? Yeah. You can use whatever you want. Yeah, other than a communication device. Yeah. Chat rooms, no. Texting, no. Nothing like that. And the format is that there. Here, let me write this down. The format is that there will be 2 questions. In other words, 2 programs, plus 1 optional bonus program. Right? So there is an opportunity to earn some bonus points on this exam. If you score more than that, I think each one is worth 50 points. So it's worth half and half. And then the bonus one is also worth 50 points. You could earn up to 150 points out of 100 points. That can bleed into your other scores. It's just points. So if you've missed a hack or something, this is an opportunity to earn some points back if you need to. All right? Okay. Well, then let's go ahead and switch gears here. This is the midterm. This is the format of the midterm that was the format's going to be the same. And I didn't have any bonus last semester, but this is the PDF that I gave them last semester. All starter code has been provided on a gist, and so I've already got that up here. I won't click on that, but I've got 2 questions here. One is to write a full program to determine if 2 circles intersect each other or not. And the second one is an exercise on arrays. Given 2 arrays, or given an array, you simply have to count up the number of zeros in it, as well as to ensure that you've got correct error handling and stuff like that. So let me go ahead and bring over the gist here. For this particular midterm, I gave starter code for both of these. They're just both programs. For the second one, I have, though it's commented out, I even gave you a simple test case so that you can run and see if it works. Yeah? It depends on the instructions. This one was different. It depends on whatever the instructions are in the midterm. Right? We will tell you what file names they have to be called, and if you don't name them, as you've experienced, you can't hand them in. So make sure that you're naming them what we tell you to. But let's go ahead and read the question for the first one, and then we'll do it together here. Write a full program to determine if 2 circles intersect each other or not. 2 circles can be represented by their xy coordinates and their radius. So the first circle is x1, y1. That's where its center is. And then a radius of 1, then that's its radius. And that's how you represent a circle. The second one is y2, x2, y2, r2. And whether or not 2 circles touch each other is simply a matter of determining how far apart their centers are. And that's just the normal Euclidean distance formula that we give you right there. Let me go ahead and zoom in a little bit more. Come on, there we go. And expand this out a bit. There we go. And move over. There we go. So if if the distance between them is less than or equal to their sum of their radii, the sum of the radiuses, then they intersect. And if not, if the distance is greater than these 2 radii, then they do not intersect. They could intersect at simply a point. That's when it's equal. But they still intersect. If they intersect at a point, they still intersect. Write a program that reads 6 values as command line arguments in the following order. So x1, y1, r1, x2, y2, r2, and outputs whether or not the 2 circles intersect. For example, if compiled to a.out, then invoking their program like this, the first circle would be centered at 0, 0, and a radius of 2. The second one would be centered at 2.5, 2.5 with a radius of 1. And it would output whether or not they intersect. I don't know if this is correct or not. With an input like this, centered at the origin with a radius of 2, and then centered at 0, 2, so that'll be, I guess, 0, 2 up here, and that has a radius of 1, they do intersect, right? Because now you've got at the origin, I won't draw a picture here, but at the origin you've got a radius of 2, so it goes up by 2 units. And then up here, 2 units up, you've got a circle of radius 1, so they certainly intersect there. Right? It's all just math. So let's go ahead and start this. First of all, you have to name your program circle intersection. And we gave that to you, circle intersection, but we didn't give you any code here. So make sure that you put your name there. Cut and paste if you want, whatever. Let me go ahead and bring in Adam over here. And new file. What was it called? Circle intersect.c, I think. Circle intersection, OK. So already, let's rename that. Circle intersection, rename circle intersection. There we go. .c. And I just cut and pasted the header that we provided. Okay. Write a full program to determine if two intersect. Of course, you'd come up here and put your name, whatever, Chris. There we go. All right, so I'm writing this full program from scratch. And if I need to do that, then I need to have my first and my includes. So include, probably going to do some input and output, right? But I'll always include the standard library, include the standard input-output library, and maybe something else, maybe the math library, because I'm going to be doing a square root calculation. Right? So include math.h. There we go. And then the start of any program is going to be your main. Int main, int argc, char argv. And this is why I recommend that you might want to come with some programs already, some skeleton programs, some boilerplate already, so that you don't have to sit here and type all this in the exam. You can focus on the actual program here. Okay? All right, so if I'm going to be reading these things from command line arguments, I'm going to be reading 1, 2, 3, 4, 5, 6 arguments, and then counting the executable file name here, I'm going to expect 7 arguments. So let's do some basic error handling. If argc is not equal to 7, then I will go ahead and quit on them. Let's go ahead and print an error message, expected 6 numbers or something, whatever, right? And then exit with an error code, say. Otherwise, now I know that there are 7 of them, the executable file name followed by those 6 numbers that I want, x1 through r2. Yeah?
Should we look to see what web grader is looking at for errors like that? Because sometimes they don't.
Oh, certainly after you've written your program, but if you don't have anything to hand in, there's nothing to grade. But yeah, you should once you've got it written, you should definitely check to see if everything works. Right? All right, so let's go ahead and pull those 6 numbers, right? We want x1, y1, r1, x2, et cetera, et cetera. So I'll go ahead and just call them what they are in the handout, x1. What kind of variable should it be? Probably a double, right? Because we even said that we could give you numbers like 2.5, right? So double x1 is equal to, how do I convert the first argument? A to I? A to f, because it's a floating point number. Argv sub 0 is the first one. Technically, that's the first one, but that's the executable file name. The actual first one, user provided, is going to be at 1. Cut, paste, 1, 2, 3, 4, 5, 6, I think I got there. All right, so y1, r1, then x2, y2, r2. Right? And instead of 1, 2, 2, 3, 4, 5, and 6. There we go. So now I've got all my inputs. Are there any inputs that would be wrong? So x and y, positive, negative, doesn't matter if it's the entire Euclidean plane, right? But what about radiuses or radii? Can radii be negative? Nope. So let's go ahead and check for that. If r1 is less than 0, or if r2 is less than 0, I'll go ahead and print an error message and then quit on them. Printf error a radius cannot be negative. Okay. Right. Whether or not the web grader is going to check for these things, that's secondary. You should be thinking about these things before, right? You should be thinking about what are the bad things that could happen and protect myself against them. Right? Exit with another error code. Otherwise, okay, I'm pretty well assured that I've got the number of inputs that I expected. They're all correct. So now I simply need to compute this right here. x1 minus x2 squared plus the difference of y squares. So double distance is equal to square root of x1 minus x2 squared. So squared. No. Some languages allow you to do this. This is not, C is not one of them. I could call pow here, or how do you square something? You just multiply it by itself. Plus y1 minus y2, and that one's squared as well. Okay? So there, I've got the distance. I've got the distance between the center of those two circles. Now what I need to do is I need to check, is that distance less than or equal to the two radii, or the sum of the two radii? So let's check that. If distance is less than or equal to r1 plus r2, then what does that mean? The distance between them is less than the radii, so they intersect. Printf, and I'm just going to grab this printout here. Circles, blah, blah, and blah, blah intersect. Let's come back over here. There we go. And instead of hard coding these values, I'll go ahead and put in %f, 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 okay, %f, %f, %f. If you want to go back and make them only accurate to 2 decimal places or whatever, remember that we're only looking for just as much information as the web grader displays. If you want to present more information, great. If you want to change it so that you have 2 exclamation points instead, that's perfectly fine. We don't care, right? x1, y1, r1, x2, y2, r2. There we go. And I ended the line, so that should be good. Else, printf, circles, here, just cut and paste this. And instead of saying that they do intersect, let's say that they do not intersect, right? That's it. And then at the end, I've got return 0. That's it. Right? Let me go ahead and open up a terminal here. Now, I could just compile this with GCC circle intersection. Is that best practice? What should I do instead? -w all to make sure that you're catching all those errors. About a good majority of the errors that we're coming across on, say, Piazza or when coming to office hours can be caught immediately simply by turning on all the warnings. Okay? Let's run it. I don't know. A circle centered at the origin of radius 1 will reach out 1 unit. And then a circle, I don't know, centered at 1010 with only a radius of 1, we would expect what out of that? Are those going to intersect? No. So do not intersect. Great. And it's 0, 0, 1, 10, 10, 1. All looks good. Give me another test case input here. 0, 0, and say the unit circle here. Give me something that will intersect. 1, 1, okay. And, 1. Yeah, they intersect. They do intersect. All right. I have a reasonable assurance here by doing at least 2 test cases that this is a correctly written program. At this point, I would upload it to the web grader, test it, see if it works. Maybe make a backup, and then you keep working on it if it doesn't. Certainly, it should not end up with an infinite loop. And if you've got when you turn in multiple programs, if you do well on the first program, everything works great. Well on the second program, everything works great. You don't do well on the third program, and you're running out of time. It's screwing up the web grader, and we're not able to grade it because it's an infinite loop or it's crashing or something like that. It's much better to just erase that program and make sure that the ones that do work are in there. Okay? Do not wait till the last second to panic and hand everything in. Make sure that you are doing it in increments. Question over here. Oh, okay. Another test case here. So let's go ahead and make it a really big circle centered at the origin. And then another one centered at the origin. but a smaller one. Right? They intersect, of course. No, it does. It's just enclosed. Of course, there's an intersection, right? Yeah, that would count as an intersection, right? Yeah. I mean, it's an entire intersection. The entire thing is enclosed, right? Yeah.
For explanation, it might be helpful. It's not just the perimeter that intersects, it can be any part of the circle.
Oh yeah. That's what, any part of the circle. That's why I said that even if they intersect at a point, right? I've got a circle at 0, 0, and a radius 1. I'll make it intersect only at a single point, which would be, we need to shift it over to 2, 0, and then a 1, right? Now these are 2 unit circles that are, this one is offset by 2, so they're only intersecting at a single point. They should intersect, and they do. Right? Okay. That one's done. Great. I don't have the web grader set up, so we can't check it here. All right, this is last year. In the second exercise, you will complete a function to determine how many zeros an integer array contains. Starter code has been provided in the file zerocounter.c. Implement the function as specified in the file. A main function has been provided to you to facilitate testing, but you will need to ensure that it is removed or commented out when you submit it to the hand-in grader, because we will be running our own main, and we can't compile your main and our main together. Right? At least that's how I set it up last semester. So here's the starter code for it, with a to-do clearly marked. What did we call it, by the way? Zero counter. Zerocounter.c. There we go. All right. So here is the prototype. The documentation here has already been written for you. So I think last semester we didn't grade on style. We just graded on correctness and design. We will be grading on style this year, though, or this semester. This function, we didn't grade on it last semester because we gave it to you. Right? The function takes an integer array and counts the number of values in it that are 0, returning that result. If the input is invalid in any way, the function returns -1. Right? That's because that's really the only thing that you can return. Can you return an error code of, say, 2? That would say that there are 2 zeros in that array. Could you return an error code of 0 indicating no error? Well, that would indicate what? That there are 0 zeros in that array. The only thing that would indicate an error is a negative value. There can only be 0 zeros or more zeros. There can't be a negative number of zeros in the array. You may use this main function as you wish to test, but you must be removed or commented out when turned in. I am going to use it here for testing. Right? The test that we give it contains 10, 20, 0, 5, 3, 0, 2, and 0. So that I should expect it, when I call it, I should expect that there are 3 zeros in the array. Okay? Now we have to write this function. What's the first thing you should do when you write any function? What? Error checking, exactly. So what could be null here? There are only two arguments here, 2 parameters. Can size be null? No, it's passed by a value. It's going to have a value no matter what. The only thing that can be null is the pointer. So if ARR is null, then what should I return? -1, as specified up here in the documentation. Right? -1. There we go. Is there any other error condition? So that's pretty much all we can check with the array. What about the size, though? It can't be null because it's not a pointer. But is there anything else about the size that could be wrong? Yeah. It could be negative, right? There's no such thing as a negative array. So let's go ahead and put in, or the size is less than 0. And I can't think of anything more at this point, but I think that that's all we were looking for. Otherwise, I need to count up the number of zeros. Right? So what kind of a loop do you want me to write to iterate over an array? A for loop, okay. For I running from 0, I is less than size I plus plus. Right? Again, that's so idiomatic. That's if you need to iterate over an array, that should just be second nature that you type that out. All right, so if check the array, if the ith element is 0, then we found another 0. So I need to increment, I don't know, number of zeros plus plus. Well, if I'm going to have a variable called number of zeros, I'd better what? Declare it. What kind of variable should it be? Should it be a double? Can there be 3.5 zeros? Probably not. It's much safer to have an integer here. Right? And the return type is an integer, so that should have been another strong hint. All right, return number of zeros. Okay, so I've been playing around with some other static analysis tools. Let's go ahead and compile this and see what happens. So GCC 0 counter. All right, I should have done what? WAll. Oh, good. If I did WAll, what do I get now? A big shiny warning telling me that I forgot to do what? I have an uninitialized variable. What is the value of number of zeros at that point in the program on line 30? Garbage, dead beef, could be 0, right? Could be anything. What should you always do? Initialize. Right, there we go. Now, when I use WAll, again, it's perfectly happy with that. I am developing a document to, I asked the sysadmins to install a few more static analysis tools, Clang, LLVM, and Clang's static analyzer tool. And I have a draft of the document up. I'll go ahead and share it later. But it's another tool that you can use to catch things like this. Again, this is just a basic linter. The static analysis tools, like I showed you Valgrind the other day, that's a dynamic analysis tool. Static analysis tools are simply just tools that you run, and then it looks at the source code and says, oh, this is a potential problem right here. Dynamic analysis tools like Valgrind, they don't look at the source code, they look at the compiled code. And they actually simulate they run the program and simulate the program and find problems at runtime. But I'll go ahead and share that document. So that going forward, you can see things like somebody asked today what was wrong with their string hack, and it's because they forgot the null terminating character in a lot of their stuff. Valgrind can find that, and I believe that Clang's static analysis tool can find something like that. GCC, just as a linter, I don't think can find something like that. So I'll go ahead and share that document later today. But otherwise, it looks like it works. Let's go ahead. It looks like it compiles at least. Let's go ahead and run it. There are 3 zeros in that array. Awesome. Right. So hand it in. What else should I test? Maybe test my error handling, right? GCC, right? And now I'm getting a warning because I'm not actually using it. All right, and run it, and I got -1 zeros in that array because that's the error code I would expect. Undo that. I could pass in a negative value here, -1 instead. GCC, and run it, and there are negative, wow. Oh, no, it was an unused variable there. And I get what I expect, a -1 there. What else? I could I'll pass in n here. I could put in more zeros, 0, 0, 0. How many would you expect now? 4, 5, 6. Run it. Uh-oh. Oh, did I not save? I thought I saved. Oh, what was wrong? Is there something wrong? There is something wrong with my code, but there's something wrong with my testing code. Yeah. That's bookkeeping. That's not something that you can handle with error handling. But Valgrind could find that. Maybe the static analyzer tool could find that. No, we wouldn't do that to you because there's no way for you to handle that. Again, there's no way to tell cross-platform reliably. Well, technically, this is a static array, so you could do that in the calling function, but not in the called function. There's no way that you can do that in C. The problem here was I added 4 zeros, but then I didn't increase the size of my array, which would be 12. Right? So GCC. Now I would expect, 7. Did I miscount? 4, 5, 6. Ooh, that's a good mystery. 12. What's wrong with 12? Did I add 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So again, it's a problem with my counting and my testing code, not with the actual function. There's 6 zeros in that array, which is what I expected. Okay. When you're doing testing, also understand that tests are not proofs of correctness. Tests can be wrong too, in which case you might have false negatives and false positives. If you have an incorrect test case and your code is incorrect, but they agree in how they're incorrect, well, then it's going to pass the test case. If you've got correct code but an incorrect test case, then your code is going to fail the test case. That's a false positive because it's saying that it passes that it fails the test when it actually passes the test. It's the test that's wrong. So tests are just provide more assurance that your program is correct. Testing like that, unit tests, functional tests like that, they're never going to provide a proof of correctness. Only a level of assurance that says that yes, your code is correct. Yeah.
So when you had 12 in there, you only had 11.
Correct.
Did it just fill that last?
It was just going off the edge of the array and still counts. I could get away with that probably if I said 100. Well, that's still small enough that okay, there are 16 zeros after that. There are 10 more zeros after that, right? It's looking at the garbage and saying that's not 0. Then it's looking at garbage that happens to be 0 and says yes, that is 0, right? And that's what's happening there. And if I'm almost positive that if I ramp this up to 100,000, it's going to be a seg fault. I can't imagine that. Yeah, I can't imagine it wouldn't let me go that far off the edge of the earth without actually catching that. So 11. Right? I'm convinced it works. Hand it in, test it, go back to the drawing board if it's not. That was only 2 exercises in 30 minutes. You've got similar 2 exercises, but you'll have an hour and 15 minutes, plus the unoptional bonus at the end. But otherwise, that was last year's midterm. Again, it's going to be worth 100 points, 150 with the bonus. That represents about 10% of your grade. The final is about 15% of your grade. That's going to be worth 150 points. There are 1,000 points in this course. There's 990. So this one represents about 10% of your grade. Well, you'll notice that the distribution of grades tends heavily, like more than 50% is towards assignments and hacks. And 75% is towards assignments, hacks, and labs, right? The stuff that you have time control over, that you can start a hack as far ahead as possible. You can start, hopefully you've started assignment 3 already. It's due in a little over a week from now, right? And you've got plenty of time to do that. So I don't particularly like tests because they're under time constraints, right? And it doesn't really prove how much knowledge you have. That's why I weigh them so much lower than, say, other classes. I don't know what's the typical calc class or math class. Exams are 60% or more. Okay, yeah, it's inverted, right? So 25% or less. Right? All right, any questions? Yeah, back there. I can provide this. Yeah. In fact, I'm at the command line, right? Yep. Just ls. Remove a.out and just everything. There you go. It's up there. Don't go to that URL. Go to there. And it's the top one. So it's live right now if you really want. I don't know if I can make that any larger, though. I could zoom in on a web page. I can't zoom in on the navigation bar. It's just gist.github.com/cburke. And it's the very first one up here. It looks like it only has one file, but there are several files if you click on that. There's another question over there? No? Okay. Well, I can go back in the archive. I never repeat an exam, at least in the coding class. So sometimes exam questions become homework questions. Sometimes homework questions become exam questions year to year. But I can go back in the archive and we can look at a year ago instead if you really want to. Yeah? All right. Here, I'll go over here. Get rid of that. That's one exam. Get rid of that. Get rid of that. 155 from... Now, if I go back to fall 16 on its midterm, the midterm back then was for the honors course, which covers C and Java in parallel. So we'll ignore the Java stuff. There's we could do this if you really wanted to, just not in Java. We do a C version instead. Otherwise, we give you a rock, paper, scissors program that you have to complete. We give you a pretty substantial program. You just have to fill in a few of the gaps, or a Hamming distance between a collection of or two arrays. So which would you want to? Let's stay away from that factorial one first. Let's go ahead and do rock, paper, scissors. Right now, first of all, I made the mistake of giving this, and maybe some people didn't know what rock, paper, scissors was. Hopefully, everybody has a version of that. If you play rock, paper, scissors, you can go rock, paper, scissors, match, right? And scissors beats paper because it cuts paper. If you've got paper and rock, rock covers it. If you've both got the same thing, two rocks, then that's a tie, or two scissors, or two papers. Those are all ties. And then I'm missing one. What would it be? Oh yeah, rock defeats scissors because it smashes scissors or whatever. All right. So I've got. Hopefully the starter code is still alive. It is good. So rock, paper, scissors. Let me just go to the raw one so I can just cut and paste everything, and come over here. New file. Rock, paper, scissors. I think that's how you spell it. Skizzers? No, is that right? Yeah, it was. Okay, skizzers. Okay. So there's a lot of code here already, a lot of boilerplate code and other code, but there are some to-dos here. There's a to-do there. This function is done for you. This function is done for you. There's a to-do there. I have to do that function. I have to do this function. Nothing in the main function needs to change, though. So what's basically going to happen here is you've got a random computer player. The computer player is going to choose rock, paper, or scissors. And then you need to print out to the user, please enter rock, paper, or scissors. And then you need to determine who wins. Does the computer win or does the user win? So I've got the first to do here is you need to define this, the player. Well, as our first pass here, how many players do we have? Two. The computer and the human. So how do I define an enumerated type to list out those two players? Human and computer. Okay. We'll go ahead and use those for now. We might need to come back to this, though. This function converts a move. What are the moves? Rock, paper, and scissors. And the rock starts at 1, so the paper would be 2, the scissors would be 3. This function converts a move to a human-readable string. It's been done for you, so we don't need to worry about that. This function randomly selects a valid move. The function has been done for you. It's getComputerMove, which returns their move. This is the first function we actually need to do here. Given the moves of the two players, that is the move from the human player and the move from the computer player, this function determines a winner, if any, or returns a value to indicate a tie. So I need to implement this function. It returns a player. Right? The way that I defined player here was human and computer. But what I didn't originally think of was, what else could happen? You could have a tie. So let's go ahead and keep all three of those things, right? Because this needs to return that player. Okay. Let's jump down here. I need to get the winner. Right? I've got the move of the human and I've got the move of the computer. How do I determine a winner? So here's the computer player. They can choose rock, paper, or scissors. Here's the human player. They can choose rock, paper, or scissors. How many possibilities are there? 3 here. For each choice over here, there's going to be 3 choices over here. So I have to write 9 if-else-if statements. You can do it that way if you really want to. I want to cut down on the amount of code, though, here. So how could I immediately eliminate 3 possibilities? Yeah, all the ties are going to be the same, right? If the human move is equal to the computer move, then we have a tie. Return tie. Right? Else, if. Right? What's another case? So I'm right there with one conditional. I've taken care of 3 of those 9 cases. Let's say that the human makes rock, or it says chooses rock. How many possibilities are there now? 2, because I've already taken care of when the computer chooses rock. So if the computer chooses scissors, right, then who wins? Return human. Right? Else, I don't need to put an if statement here because what's the only other possibility? The human has chosen rock. We know that the computer has not chosen scissors and not chosen rock, otherwise it would have been caught up here. So the computer has obviously chosen paper, and thus the computer wins. Right? All right. Else if the human chooses rock, paper, let's go in order. Then we have 2 more possibilities. If the computer chose, well, I've already taken care of if they chose paper, that would be a tie. If the computer chose rock, then who wins? Human. Else, return computer one. And the only other case here is else, so I don't even need an if statement here, but I'll go ahead and put it in. If the human is equal to rock, paper, scissors, then I have 2 cases to consider. If the computer chose rock, then who won? Rock beats scissors, right? So return computer. Else, return human. There we go. And I did put an else if up there because are there any other possibilities? We could do error handling here. Printf, illegal state, right? We'll go ahead and say that computer or human is equal to whatever they chose, computer is equal to whatever they chose, and the line human computer. And then because, well, they were able to choose something other than rock, paper, or scissors, so we'll go ahead and exit after giving that error message. And that's it. So we did this. It's always nice to get rid of to-dos. I did that. Let's go ahead and get rid of this to-do as well, because I did it. It's done. And the last one I need to do is this method prompts the user to input their move, rock, paper, or scissors. If the user gives invalid input, it reprompts them until a valid input is provided. The function returns one of the enumerated move values corresponding to the player's choice. So we're going to prompt the user to enter in rock, paper, or scissors in some way. I'm simply going to give them a menu. Choose 1 for rock, choose 2 for paper, choose 3 for scissors, because then I don't have to write too much code. Right? It'll take care of that for me. So let's go ahead and prompt the user for input. Printf, enter a choice and the line. Let's make a nice printed, nicely formatted menu. 1 is equal to rock, right? There we go. 2 would be paper, scissors, 2, 3, paper, scissors, right? And then I will read the input from the user. How do I read input from the standard input? Scanf. And what will my placeholder be here? Percent. What type am I reading here? I don't read. I can't read an enumerated type because an enumerated type is actually what? It's a number, 1, 2, or 3. So I'll just read in an integer. So I'll need an integer input. Is that correct? Let's go ahead and ask GCC rock, paper, scissors. Warning. Well, first of all, there's an error somewhere. Else if, okay, I need to fix that. But warning, what am I doing here? What did I forget? Ampersand, good. What was the error up there? What line? 91? Did anybody else see it? Else if Oh. Oops. Where does it, this ends there? Yeah. This else if should be on this one, right? There we go. And I think I might have screwed it up elsewhere too. So that matches, yeah, that matches, that matches. Okay, good. And that matches. Okay, so I think that that's taken care of, but my indentation is off, so I'm going to miss points on the formatting, but of course I could take care of that. Oops, nope, what, darn it. All right, this matches that, this matches that, this matches that, and then this matches that, and so I am off by 1 here. There we go. There we go. All right, good. Ignore that warning. But otherwise, I should come back here and fix all my indentation, or I could cut and paste it and put it into a formatter online because I've got access to a formatter. I can go ahead and get full points on that if I want to. All right, so that works. If they don't enter 1, 2, or 3, then what should I do? I need to reprompt them. So if the input is less than 1, or if the input is greater than 3, then reprompt. So should I go ahead and go, all right, cut, paste this stuff right here. There we go. Is that a good idea? Is that a good design? Yeah, I'm going to need a loop anyway, right? So let's go ahead and say that while the input is invalid, keep asking them, right? Now, I don't need to do all this stuff twice, right? You should rarely have repeated code here. Instead, what value could I give to input here to force that while loop to actually execute? Could I give it 1? That would always be rock, all right? Give it a 0. Now the while loop will execute, and it'll continue to execute until you enter in 1, 2, or 3. Right? And at the end, what should I do? Return input. By starting the enumerated type at 1 here, I can just say, well, return the input directly. It's either 1 for rock, 2, or 3 for paper and scissors, respectively. Right? Let's go ahead and run this. Okay, that warning went away. A dot out. Enter a choice. What should I write? What should help me? Okay, let's do some error checking first, right? -10, it should reprompt me. 20, it should reprompt me. Good, that's working. All right, now what should I play for real? 2.5. That'll just that will probably just. Oh, let's find out. All right, looks like I chose paper there. That's because it simply just well, it truncates, but it's only parsing up to the decimal point, and the decimal point might still be in the buffer there. So the computer's mighty scissors defeated my pathetic paper. Is that correct? Scissors beats paper? Yep, okay. Let's play again. I'll choose rock this time. A winner is you. The rock defeats the computer's scissors. That's correct? All right. Winner is you. Tie. We both chose rock. Don't think like a computer. There, paper defeated rock. All right. All right, let's try a few with 2. All right, we both chose, oh, there, wait, no, I won because I chose paper and that defeated rock. That's correct. I won again. Tie, we both chose paper. Okay, there. Well, no, I haven't lost yet. Okay, there we go. I lost with paper, finally. Probably want to try it also with scissors. Tie, tie, a winner, and tie. Can I at least get a loser here? There we go. Now I finally lost. The way that we actually tested this, since it was randomized, is we ran it 100 times, and we ensured that all 9 scenarios were there. And if not, then we took a closer look, and we knew that we either said it was wrong or all right, reran it, and then we have a higher chance that all 9 scenarios are there. Right. Yeah.
So what if the user types out wrong instead of just
Like mashes the keyboard?
yeah, so instead of just putting 1 for rock, they do rock
Ooh. There we go. Don't worry about that. That's a buffer issue right there. Say again.
So if they were playing and typed rock out,
Oh, they typed rock like this? Yeah, the same thing. They mashed their keyboard. We wouldn't have done that in the tester, no. That's going to require a lot more. The way that you could protect yourself against that is by capturing the error, the integer value from scanf, and then if x is not equal to 1, printf, don't mash the keyboard, exit. All right, run it again. Rock. I hope this works. Yeah, don't mash the keyboard. Right. All I'm doing there is, all I'm doing with this return code, which we never really covered because it's not that useful, is x represents the number of placeholders that were matched. If I mash the keyboard, 0 placeholders gets matched when I would have expected 1 to get matched. But we're not expecting that. We wouldn't throw something like that at you. Other questions on this? Otherwise, we have plenty of time. Do you want to do the second one, or the third one, I guess? Hamming distance? Yes? No? Well, you're free to leave if you don't want to. But I'll go ahead and continue it so that it's on the video, and so that if you want more practice here, you can have it. So the Hamming distance, and this will be the last one, though. The Hamming distance of two strings or collections is of equal length is defined as the number of positions or elements in which they disagree. For example, the two binary strings, here we go, here they are, I'm not going to read them out. They have a Hamming distance of 3 because if you can see it, they're bolded. The fourth bit, the fifth bit, and the last bit, they all are different. 0, 1, 1, 0, and 1, 0. But otherwise, all the bits are the same. So its Hamming distance between these three, or between these two binary strings is 3. So we're going to write a program here, write a function. The starter code is available in hammingdistance.c. Follow the specifications provided in the documentation. So let me go ahead and go over to that and go back. Nope, okay, up there. Here's the Hamming distance for C. New Hamming distance.c. There we go. So let's read all about it. It takes two integer arrays, A and B, and the size, they're expected to be the same size, as well as a pass-by reference value, hamdist. That's so that it can return an error code. This function computes the Hamming distance of the two binary arrays, both of the specified size, and places the value in the last parameter. An error code is returned for any potential errors, including the case that either A or B contain non-binary data, so if they contain 2 or 5 or negative 10, then we're going to return an error code because that's not binary data. Integer values other than, integer values other than 0 or 1, or any other issues that might come up. I've got another main here that you can use to test it, and we will use that. There we go. So let's go ahead and implement this. I should do some basic rudimentary error checking, like if A is null, or what else could be null? Increase the size here. B could be null. Is that all that could be null? The hamdist could be null. If any of those things happen, I'll return an error code. Right? All right, that's good for now. Let me go ahead and iterate over both arrays at the same time, right? Using, again, this should be just instinct now. For I running from 0, I is less than size, I plus plus. What I want to check is if they have the same binary value. If A sub I is not equal to B sub I, then what should I do? If they're not equal, I closed the example now, but if they're not equal, like this fourth bit right here, 0 and 1, that contributes 1 to my Hamming distance. They're the same, don't do anything. They're the same, don't do anything. They're the same, don't do anything. Oh, they're different, add 1. They're different, add 1. Same, don't do anything. They're different, add 1. You get a Hamming distance of 3. Right? So if they're not the same, I'll increment, say, a counter, plus plus. That means I need a counter. Int counter. What should I do? Initialize it, always. Right? And then, do I return counter? Is that what the specification says here? The value should be placed in the last parameter. How do I do that? I don't return it. How do I place it into the last value? Hamdist is equal to counter. Is that correct? The thing on the left-hand side is a pointer. The thing on the right-hand side is a regular old variable. How do I make the thing on the left-hand side into a regular old variable? Star. Right? Dereference it. Right? It's a reference, so you dereference it to make it into a regular variable. And that's going to be star. Right? If you need to, just put that on a cheat sheet. Right? Regular variable to pointer, ampersand. Pointer to regular variable, star. Right? Dereference. And then, of course, I need to return 0 if nothing went wrong. Here I'm returning 1. What else could go wrong, though? If it contains non-binary data. So I probably need to check that inside my for loop. If a sub I is, well, binary data is 0 or 1, right? So one way I could check this is if it's less than 0 or a sub I is greater than 1. Or, what else do I need to check? B sub I, if that's less than 0 or greater than 1. Then I will immediately stop and return some error code. Okay? That looks good. Of course, I need to call it. What did I call the function? Hamming distance. Capture the error code. Hamming distance of A, B, their size is n, and then I need a variable to store the result, right? So int result. I'm going to pass that by reference. It requires a pointer. Is this a pointer? Nope. So take a pointer and make it into or take a regular variable and make it into a pointer. Now what is that? Ampersand. Right? And then let's print it out. Printf. Error equals %d, and then result is equal to %d and the line. Error and result. Right? What would you expect from this? It's all binary data, so I would expect an error code of 0. And a Hamming distance of, we already said, 3. Let's try it out. Excellent, it works. I could come back here and make it so that those are the same. Now I would expect a Hamming distance of 2 and an error code of 0. All right, that's looking good. What if I put in 5? What would you expect now? An error code of 1, and it doesn't matter what the result is. There you go. There's a garbage result right there, right? Because of an uninitialized value. Right? We never set result. It probably got corrupted in this function, but it doesn't matter because we got an error code of 1. We shouldn't expect the result to hold any particular useful information. There was an error. Right? What else could I attest? I could test to see if I've got non-binary data up in A. And same thing here, but different garbage. Right? I could test what? What are some edge cases that you could test? What about that? What kind of a Hamming distance should I expect from that one? 0. CCC. Run it. Good. Error code of 0, result of 0. What if I did 1, 0, 0, 0, 1, 1, 1, 0? What kind of a Hamming distance should I expect there? I made it completely opposite, so 7? Good. All right. Questions on that one? Yeah. Negative what? Oh, you mean just like put a negative in here? Yeah. -1? It should give me an error code of 1, right? Unless you saw a mistake I made and are trying to call me out on it. Error code of 1 in garbage. Good. All right. Here's a good question, though. What about a -0? we wouldn't throw that at you, but it's not going to be equal, but I don't know if it's going to be less than. So let's, honestly, I don't know. Error of 0, oh, wow, cool. It's not bad data. Negative 0 is 0. So there you go. That's a good question. That's not going to compile, right? H. Yeah. It's going to think that's a variable, and it's not a variable. So that's not even going to compile. Yeah?
What if your arrays are different sizes?
That's a good question. There's no way that you can detect that, right? It's your responsibility to do the bookkeeping with respect to arrays. So there's no way that this, in the calling function you could do that because these are static, but if they were dynamic, if you're not doing your own bookkeeping, there's no way to know. There's definitely no way to know up here because the underlying assumption is that they're both the same size. There's another question over here? No? Okay. All right, there's no reliable way to do bookkeeping automatically, right? You have to do that yourself in C. All right, then have a good break and good luck when you come back on Wednesday.